Hello there. Today we'll be doing regular expression matching. This is another 2D programming problem, number 149. Okay, so in this particular problem, we are given two strings and we're trying to match the regular expression p to s. So in this particular expression here, will a match s? S, which is two a's? No, because a does not match entirety of s. However, p a star does match because star means is 0 or more, and the period and star means that it'll match any character 0 or more times. Okay, so the idea here is that we need to know when to match, when to not match, and how to match. So first thing is that we can see that these two match. And how do we tell that? So suppose we have the I and J pointer at this particular location. We check if the next item is a star. And if it is, that means to us, let me just put this on two separate lines because this is going to not be pretty. Because I will be typing. So if that's the case, we can move I and keep the J at the same place and keep repeating this process until I has completed its process. And once I has completed the process, we can now move on from J and get this to the point where it is also the end of the string and we're done. And that means it's a true. However, if suppose we match, we have this issue here, the B, and we suppose we match, we see a match, we move it again, and then we don't have a match anymore. That means we have to move the J, but then the J is out of bounds. With the J is out of bounds, that means that this is we should return false. So let's write that down. I and J out of bound equals true, and J out of bound equals false. But suppose that J is in bound, and well, that doesn't happen. Okay, anything else? So what if we match this not here, this period? Well, at this particular point, we're trying to match a period, and that means we need to increment both items forward if they are if it's a period, or if it is equal, the same. So in any case, we need to match and move both items forward. So the rules are move both items forward upon match except check for star, and if match, move I forward. Okay. And with that, I think we have basically matched all situations. Anything else, everything else, we would return false. Because we would not be able to move forward, there's no match, and that means we can't move forward with that particular case. And so I think we can start coding this up. There are many great solutions here for this particular problem. It's a 10th problem, and there's a solution here. But let's just go over it. I think a video does help. One thing to note is that if we do a DP, that means if we do a dynamic programming and retain our keys of I and j, what that particular point in time means, we would return I and j. This is n squared time. Well, n times m, or I times j time. We will just operate on that particular I and j once. But if we don't have this cache, this DP, we will be doing it multiple times. The reason being is that once we move we'll split up the DFS calls, because we have different options. We can choose to not move forward or to move forward. We can choose to move a single item or move both items. Yeah, we have multiple ways of doing this. So okay, so DFS of I and j, and we're gonna pull a return a bool. So if I is greater than or equal to length of s, and j is equal to length of p, then we can return true. Else if j is equal to length p, and that means we can return false. Otherwise, we found I and j in the DP, so we can return DP of I and j. So one more thing is that the space complexity is I times j, which is the length of s times s length of p. Okay, so let's check if there's a match. That's a very important piece of information that we'll need for both whether or not we see a star or if they're equal. So if it's I is less than the length of string, and s of I is equal to the p of j, or the p of j is equal to a dot. So if we have once we know the match, if we want to know if it's a problem for us, if the next item ahead is equal to a star. So if it is equal to a star, that means that we can choose to use or not use this item. So DFS of I and j plus 2 means that we will be skipping this item. We'll be using 0 of it. Or we can return, if it's a match, and a DFS of I plus 1 j. That means we'll be moving 1 forward on the s side, on the s string, and remaining in the same area. So let me just do a comment. Don't use, and well, let's just use. And then we'll return this DP after caching it. Otherwise, at this point, that means it's a single item, and if it's a match, that means we can return a DP. At this particular point in time, that means it's not, there's no separate character. This is going to be equal to the DFS of I plus 1 and j plus 1, because we can only move forward by 1. And if they're matching, we should move it forward. Otherwise, and then return DP of I and j. Otherwise, we're going to return false. The reason why we're going to return false is because they're not matching. And if there's no match, then there's nothing we can do at this particular point. So let's end it quickly. Okay, let's return DFS of 0, 0. Submit. Oh wow, that's pretty quick. A funny thing is that this particular problem allows us to submit this problem without the dynamic programming approach, without caching the result, and this results in a runtime of 2 to the n, because of the decisions, each decision we need to make, branching off from one decision. So what I mean by that is that suppose we have a that means we can choose, and then our you know like S is AA and P is A star. That means we need to like move. We need to run DFS twice. We need to do I and j plus 2, and we need to run DFS of I plus 1 and j. This means that we're either choosing to use or not use. With that, we already, with one item, we already have 2 different moves that we can make. And then we need to make additional moves as we have a longer and longer S. We have to check if we're going to use it or not. And this just basically means that each of these decisions have 2 decisions. And these decisions have 2 decisions. This gives us 2 to the n power. So each layer of the tree gives us more and more decisions that we need to make. However, with the DP, we store those decisions so that we don't have to redo the work. So let's remove the DP, and this is pretty simple. We just have to do this, and we have removed the DP. And with that, we can see the how much longer it takes for us to do this particular problem. We might get a runtime error, but it looks like we did it. Hey, okay, so we got that particular answer without the storage, and it took us many more times, about 20x longer, maybe more than that, 50x. Yeah, 50x. 550 times 40 is 2000. So that much longer to get this particular problem to complete. Anyways, I think we learned a lot today. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.